Mercedes-Benz Vision EQXX First Ride, Mercedes Megameter EV. Behold the most efficient Mercedes ever, the Vision EQXX. On Tuesday, April 5, this experimental concept car drove 626 miles, or 1,007 kilometers, just over a megameter from its birthplace in Stuttgart, Germany, up and over the 6,900-foot Gotthard Pass in Switzerland to the French Riviera on a single 100 kilowatt-hours battery charge. The car averaged 56 miles per hour by strictly adhering to all speed limits, peaking at 87 miles per hour on a no-limit stretch of Autobahn. They made two 15-minute bio-brake stops, arriving in Cassis having consumed only 88% of the battery with 87 miles of range remaining, certified by German TV authorities. We traveled to the nice design center that penned the exquisite EQXX to learn how this impressive feat was accomplished and to get a sense of how close the forthcoming EQC sedan might come to achieving similar results. Prioritizing efficiency efforts. The overarching goal set for the EQXX team was to achieve a single-digit kilowatt-hour/100 km consumption figure. 9 kilowatt-hour/100 km equals 233 mpge. The Riviera run yielded an overachieving 8.7 kilowatt-hours per 100 kilometers, 241 mpge. The team prioritized its efforts proportionally to the forces acting on such an electric compact sedan at speed. 62% of the energy expended goes to overcome aerodynamic forces, 20% to overcoming the vehicle's weight and rolling resistance, and 18% goes to drivetrain losses. Lowest drag without fender skirts. Aero was obviously the development team's #1 priority, and wheels are a huge problem. Front wheels typically create 1/3 of a sedan's aero drag. The easiest and ugliest way to fix this is by fairing the wheels into the bodywork with skirts or spats, but the team in Nice managed to minimize wheel drag with very smooth unvented wheel covers, by specifying the tire sidewall contours and demanding all labeling be carved into the rubber, not embossed on it, and by insetting the rear wheels almost 2 inches relative to the fronts, putting them in the wind shadow of the front wheels. The considerable plan view taper of the greenhouse makes possible those sensuous rear shoulders that mask this design don't. It also benefits aero, but at considerable cost to rear seat shoulder room. The next biggest aero advance, good for 0.01 cd, is the rear diffuser, which extends almost 8 inches and drops down 3 degrees at speeds above 35 miles per hour to work with the rest of the sharp edge that rings the tail of the vehicle to manage airflow separation and minimize drag-inducing turbulence. The rest of the story is more conventional: smooth underbelly and A-pillars, smaller, more aerodynamic mirrors, an underbody cooling plate that rejects heat directly to air passing under the car, meeting most of the vehicle's cooling needs, so the conventional radiator need only be used for climate control or extreme heat. That's fed by shuttered openings in the lower grille that exhausts air through vents. The end result, a drag coefficient below 0.17, and a frontal area of 2.10 square meters for a total drag reduction of 29% relative to the EQS sedan, 0.20, 2.51 sqm. Weight savings. Mercedes claims the EQXX tips its scales at 3,870 pounds, a bit less than the 3,902-pound single-motor Tesla Model 3 long-range we weighed in 2017 with a smaller 75 kilowatt-hours pack. A more energy-dense battery pack that relies on passive cooling is partly responsible. At 1,091 pounds including the one-box charger/controller, it weighs about the same as a Model 3's actively cooled 75 kilowatt-hours pack. The body structure employs a mega casting in the rear that, unlike the one in the Tesla Model Y, features bionic design. The team utilized ZBrush digital sculpting software, like Disney/Pixar used to render Shrek, to shape this mega casting, as well as the cast front shock towers, die-cast rear shoulder belt anchors, and the 3D printed aluminum windshield wiper motor support. These parts only feature metal where mechanical stresses require it, with lightning holes where no stress flows. Where necessary, these holes are covered by UBX polymer panels produced from post-consumer waste. There are also composite springs, a carbon fiber rear motor carrier, and aluminum brake rotors. Motor/battery optimization and solar roof. Mercedes has yet to divulge full specifications on the EQXX's battery and motor, except to say that they operate at 900 volts to further reduce amperage, cabling size, and mass, and overall system losses. The battery still utilizes nickel-manganese-cobalt chemistry employing high silicon anodes, and is said to deliver 95% of input energy to propulsion. 90 is more typical. The 241 horsepower Mercedes-developed ETS 2.0 based motor employs a novel stator winding leveraging Formula E technology that places more copper near the rotor for greater power and efficiency. The roof and rear window area are covered in 19.4 square feet of 25% efficient photovoltaic panels intended to largely power the infotainment and other non-propulsion systems, extending the car's range by up to 16 miles on a sunny day. Riding along in the EQXX. As engineering development vehicles developed from scratch 18 months ago, this one seemed uncannily production-ready. Its 47.5-inch 8K resolution pillar-to-pillar micro-LED, not OLED, screen rendered dazzling navigation info, with an intuitive interface and zero-lag responsiveness. 5 different data visualization tech screens displayed oodles of engineering and eco-coaching info in sharp gamer graphics. The sun's angle of incidence and wind direction are used to precisely forecast solar energy gain, and the aerodynamic effects, the road grade, and traffic forecast helps estimate instantaneous range remaining throughout the journey.
Thanks for watching. Drop a like. Leave a comment. And don't forget to subscribe to watch more videos like this.